I'm Anil Kumar sharing with you questions from previous test paper on compound and conditional probability. We have 12 questions in this test paper. You can pause the video, copy these questions, and then we are going to answer these questions one by one. So you can see question number 1 to 3 at present. What is the probability of randomly selecting either a club or a non-face card from a standard deck of 52 cards? Now these two events are not mutually exclusive, and when we say or, we are actually looking into adding their probabilities and excluding the common elements, right? So not mutually exclusive event. In question number 2, two balls are randomly picked from a set of 4 red balls and 5 green balls without replacement. Find probability of picking 2 red balls. Now this is without replacement, so it's a case of independent or dependent. What do you think? While it is case of dependent event, the sample space changes. The probability of second red ball is different from the probability of the first red ball. So you have to take care of that while answering. Question number 3. Peter works in car sales. Over a period of time, he spoke to 500 customers. The experimental probability of a customer going for a test drive is 20%. If a customer went for a test drive, there was 5% conditional probability that Peter made a sale. So we are talking about conditional probability. Assuming that no sales were made without test drive, how many sales did Peter make over this period of time? Right. So this is conditional probability. We have already given you the conditions. So if you do product of these probabilities, you will get the answer, right? Question number 4 here is, if Mike does his homework today, the probability that he will do it tomorrow is 0.8. The probability that he will do his homework today is 0.7. What is the probability that he will do it both today and tomorrow? So from now, we'll take a few examples on conditional probability, as we already have, right? So I hope you have already copied these questions. Let's move on. Here we have question number 5 to 8. Question number 5 is, a fair die is rolled. Consider the event A of getting 3, 4 or 5, B as 2 and 3. What is the probability of A when B occurs? And what is the probability of B when A occurs? Question 6. If A and B are two events such that probability of A is equal to 0.3 and probability of B is 0.6, and probability of B when A has happened is 0.5, find probability of A when B is given to you. Question number 7. A couple has 2 children. Find the probability that both are boys if one of the children is a boy, the elder one is a boy. Question number 8. If probability of A is 0.4, probability of B is 0.3, and A and B are mutually exclusive events, find the following: probability of A or B and probability of A and B. So with that, you get some idea about mutually exclusive events, and before that, we talked about conditional probability with given probabilities. Question number 9 to 12. I have a pet dog and a cat. The probability that the dog will be at the door to greet me when I get home is 91%. The chances that both dog and cat will be at the door is 15%. What is the probability that cat will come to the door given that the dog is already at the door? Conditional probability. Question 10. A committee of 4 students is selected at random from a group consisting of 7 boys and 5 girls. Given that there is at least one girl in a committee, calculate the probability that there are exactly 2 girls in the committee. Now, these are thinking questions. So they may require permutation combination and some more concepts which you have already learned. Question number 11. 3 identical balls with different colors are distributed in 3 baskets. Find the conditional probability that all the 3 occupy the same cell, same basket that is, given that at least 2 of them are in the same cell, right? Given that at least 2 of them are already in the same cell. The last question is question number 12. 2 integers are selected at random from the numbers from 1 to 11. If the sum is even, find the probability that both the numbers are odd. If the sum is even, find the probability that both these numbers are odd. I hope these questions will give you good practice to prepare for your own test. Now, we'll take these questions one by one and see how to answer them. Thank you. Now let us solve these questions one by one. Question number 1. What is the probability of randomly selecting either a club or a non-face card from a standard deck of 52? So we know that in our sample space we have 52 cards. So n of s is 52. Now, how many clubs are there? So C for clubs, let's say. So we have 13 cards of each suit. So clubs, we have 13. We're looking into non-face cards. Let's first figure out how many are face cards. The face cards are 12. Jack, King, Queen, 4 suits. They are 12. So from there, we know that the number of non-face cards, that is F prime, is equal to 52 minus 12. 52 minus 12. And that gives you 40. So we have 40 non-face cards. So in our case, we are looking into 2 categories. One is non-face cards and the other is clubs. So as you can see, there is an overlap between these two, right? Since out of 13 clubs, 10 of them are non-face cards, right? So if I'm saying that this is event C and that is non-face card, in that case, we have Jack, King, Queen of clubs, and then we have ace to 10 here. Out of those 40, 10 are common, 30 remain there, right? So that gives you the probability. If we add them, we get the probability of what we're looking for. That is, we're looking for probability of clubs, or that means union non-face cards, right? So that is going to be, the denominator is going to be 52, the sample space, and the favorable number of cards are number of clubs, which is 13, plus number of non-face cards, which is 40, take away what is common, which is intersection of these two, which is 10, right? So that gives you the result, which we could also count from here. So we have 43, and that also gives you the same result. 50 take away 13, 53 take away 10, which is 43. So that gives you 43 over 52 as the result, right? So that is the answer. Question number 2. Two balls are randomly picked from a set of 4 red balls and 5 green balls without replacement. Find the probability of picking 2 red balls. So that means the first pick, right? So first pick could be red or green. Now we are interested in the red balls, so we'll look into that probability. Since there are 4 red and 5 green, let's make this. So we have 4 red and we have 5 green. Therefore, the probability of picking red at this stage is 4 out of total of 9, right? So, 4 out of total of 4 plus 5, 9. Now, once you pick the red ball, then the second time when you are picking the red ball, now here again there are 2 possibilities, of course. But at this stage, since one has been picked, we are left with 3 red balls. But still there are 5 green. So the probability for picking up the next red ball will be 3 out of 8, right? 3 out of 8. And therefore, in this particular case, probability to pick 2 red balls will be product of these two, which is 4 out of 9 times 3 out of 8, right? So this is basically, as you can see, is a dependent event. And probability of both red balls, that means R and R, that is intersection, is basically equals to probability of first red plus probability of second red when the first one has happened. So, I could have used the events as A and B. And so what I'm saying here is, let's write it like this. Probability of A intersection B is equal to probability of A plus probability of B when A has already occurred, right? So that is the result, right? So which you can simplify 3 times 3 and 4 times 2. So you get 1 over 6 as your solution, right? So let's move on and do rest of the questions. Peter works in car sales. Over a period of time, he spoke to 500 customers. The experimental probability of a customer going for a test drive is 20%. So out of 500 customers, 20% went for test drive. If the customer went for a test drive, there was 5% conditional probability that Peter made a sale. So that times 5% conditional probability, right? Assuming that no sales were made without test drive, how many sales did Peter make over this time period, right? So here we have a conditional probability. Right? So that is to say, if I'm choosing event A and this is event B when A has occurred, do you see that? So how many sales did he make? Those were the contacted people. So 500 times 20 over 100 times 5 over 100 gives you the result, right? So we could simplify this and get our result, right? So that is how we could do it. 5 times 2 as 10, right? So 5 times 2 as 10. So this is 5 sales. So that is how you could answer, right? Question number 4. If Mike does his homework today, the probability that he will do it tomorrow is 0.8. The probability that he will do his homework today is 0.7. What is the probability that he will do it both today and tomorrow, right? So what we are given here is, let us say probability of doing homework today is, let's say probability for doing homework today? Let's call this as event A, right? And this is given to us as 0.7. Now it says, if Mike does his homework today, the probability that he will do it tomorrow is 0.8. That is a conditional probability, right? So we are saying conditional probability B if homework is done today, A, right? So B is homework being done tomorrow if A has been done today. So that is the conditional probability 0.8. What we really need to figure out is what is the probability of both A and B, right? A and B. This is what we need to find. So probability of both A and B is probability of A times probability of B conditional probability, right? So that is how we can actually find this particular answer. So that gives you the result as probability of A is 0.7 times probability, conditional probability given to us is 0.8, and that gives us 0.56 as the answer. So I hope that is clear, right? So that is a conditional probability case. So when the events are dependent, in that case probability of A and B is product of probability of A with its conditional probability, right? So we can write that probability that he will do both today and tomorrow for both today and tomorrow is 56%, right? So let's move on. Question number 5. A fair die is rolled. Consider the event A 3, 4, 5, B as 2 and 3. What is the probability of A when B occurs, and what is the probability of B when A is given to you, right? So these are conditional probabilities. In the sample space, the number of items which we have or elements are 6, right? So we have 1, 2, 3, 4, 5 and 6, correct? So basically I should write space, and number of elements in space is 6. Now consider the event A, which is 3, 4 and 5. So since A is 3, 4 and 5, let's say A is 3, 4 and 5, probability for A is 3 out of 6, which is half, right? Now event B is 2 or 3, these two numbers when you roll the dice. So the probability of B is 2 out of 6, which is 1 out of 3. Now let us also find what is the probability of A and B, right? That is kind of important whenever you want to find conditional probabilities. So A intersection B is what? So A intersection B is 3, and therefore the probability for A intersection B, that means A and B, is 1 out of 6. Since there is only number 3 which is common to both A and B, right? Now we can find both these conditional probabilities. So let's calculate. The first one is probability for A when B is given to us, right? So in that case, this is equal to probability of A intersection B, A and B, divided by the probability of B, right? So this one. So intersection is 1 over 6 divided by probability of B, which is 1 over 3, right? So that is how we get 3 over 6 or half. For probability of B when A has already occurred is probability of B when A has already occurred is probability of A and B divided by probability of A, which is A and B, as we know, is 1 over 6 and probability of A is half. So that is 2 over 6 or 1 out of 3, right? So that is how you could actually find both the conditional probabilities, right? We'll actually use this concept as we move forward in these following 3 or 4 questions. Question number 6. If A and B are two events such that we are given probability of A equals to 0.3, probability of B given to 0.6, and we are given probability of B when A has happened is 0.5. We want to find probability of A when B occurs, right? So this is what we need to find. So in these questions, the idea is first to find probability of both happening together, that is A and B, right? So that is what we have to find. So this is the first step. Once we do that, we can get the result, right? Now, we know the probability of B happening when A has occurred. It could be written as probability of B when A has occurred as equals to probability of A and B or B and A, one and the same thing, right? Let me write A and B divided by probability of A. Now we are given this is 0.5 equals to A and B we have to find. Let me write this in short form, A and B. And probability of A is given to us as 0.3. So that gives you that the probability of A and B is equal to 0.5 times 0.3, which is 0.15, right? Now we can find the probability for A when B has already happened. This is probability of A and B divided by probability of B. Probability of A and B is 0.15 divided by probability of B is 0.6, right? So you can now simplify this or use the calculator to write the answer. So we have 0.15 divided by 0.6 equals to 1 out of 4. So the answer is 1 out of 4. I would like you to go through these steps once again. They will really help you to understand how to figure out conditional probabilities using this formula, right? Question number 7. A couple has 2 children. Find the probability that both are boys. If one of the children is a boy, the elder one is a boy. So we have 2 different conditions here. I would like you to pause the video, answer this question, and then look into my suggestions. So let us try to do this question with the help of tree diagram and also algebraically, right? So let's say that the couple has 2 children, that is, the children could be boy or a girl. So for the first, let me write it could be boy or a girl. I'm using subscript 1 to say the first child. Now for the second child, again it could be boy or a girl. So we already have a boy. Now we have second boy or a second girl. Now in this case also we could have second boy or second girl. Now these combinations will give you 2 boys, first and second, first boy and then a girl. We have first girl, second boy, first girl and second girl. Now the tree diagram can actually help you answer all these questions. It says a couple has 2 children. Find the probability that both are boys if one of the children is a boy. Now as you can see here, we are looking for probability of both boys. Now we are giving conditions. So the first condition, let's look into the first condition, and that is one of the children is boy. So what qualifies? One of them is a boy, that means this qualifies, that qualifies, and this qualifies. So clearly the answer is 1 out of 3, right? So we get 1 out of 3 as when one of the child is a boy, correct? Now the second case, let me use different color to explain the second case. In the second case, we are looking for the elder one is a boy. Now, the elder one means, well, which I should have written B2 here. So for that elder one to be a boy, we have two options. One is this and the other one is right there. So out of 2, there's only one in which both are boys, right? So it is 1 out of 2. Do you see that? So that is how very easily we could actually answer this question from a tree diagram, right? So I'll prefer to use tree diagram to answer this question. However, you could have the same approach as we did in the previous question. Defining our events A, when say a couple has 2 children, find the probability that both are boys. So what we can say is that event A is both boys, that is B1, B2, right? So that becomes event A, and event B is one of the children is a boy. That means the combination could be B1, B2, one of them is a boy, or B1, G2, first one is a boy, or the second one is a boy, G1, B2, right? And then we could have the third event C, in which the elder one is a boy, right? So the elder one being a boy gives us 2 possibilities, which is B1, B2 or G1, B2, right? So that gives us 2 possibilities. To find the conditional probability that one of the children is a boy, right? So we are looking for find probability that both are boys. That is probability for A, both are boys. If one of the children is a boy, so one of the child is a boy is B, right? So that is in case equal to the probability of A and B over probability of B, right? So which is in this particular case probability of A and B. So out of these two, what is common? Only one is common, right? So probability of A and B is 1 out of 4, right? So where there are 4 conditions, 1 out of 4. So we can write this as 1 out of 4. Divide by probability of B, which is 3 out of 4. These are the 4 combinations, right? 3 out of 4. And so what we get here is 1 out of 4 divided by 3 out of 4 is 1 out of 3, which is what we got earlier. Is that clear? Now we could find probability of A when elder one is a boy, that is C. Now in that case, again, we are looking for probability of A intersection C this time divided by probability of C, right? Let me push this a bit. Now as far as intersection is concerned, there is only one common element between these 4. So we have 1 out of 4 divided by, there are 2 out of 4, so probability is 2 out of 4, and that gives you the result half, which we got earlier from the tree diagram, right? So I hope it makes sense that if we have only a small number of combinations, as we have in this particular case, tree diagram is a faster approach. Okay. Let's move on to the next question. Question number 8. If probability of A is 0.4 and probability of B is 0.3, A and B are mutually exclusive events, find the following: probability of A or B and probability of A and B. Since we are given that A and B are mutually exclusive, we can make two circles which have nothing in common, right? So that is what we are saying, mutually exclusive, right? So these are the events A and B. Now, since they are mutually exclusive, A or B is combination of these things, so we can write probability of A or B is equal to sum of probabilities, right? Probability of A plus probability of B. Since there is no intersection, we don't have to subtract anything. So we get 0.4 plus 0.3, which is 0.7. So that is part A. For part B, probability of A and B is, there's nothing common, so it is 0, right? So is 0. So that is how you could answer this question. It is more to understand the concept of mutually exclusive events. Question number 9. I have a pet dog and a cat. The probability that the dog will be at the door to greet me when I get home is 91%. The chances that both dog and cat will be at the door is 15%. What is the probability that cat will come to the door given that dog is already at the door? So let's write down the probability of the event A, which is dog at the door, which is given as 91%, right? Now it says the chances that both dog and cat, that means probability for dog and cat, is given to us as 15%, right? So when we are given numbers in percent, we could write in decimals. So we could write this as 0.15. What we need to find is the probability that cat will come to the door. So we want conditional probability. Cat will come to the door when dog is there, right? That is what we need. And this is equal to probability of dog and cat being at the door divided by probability of dog, right? So which is 0.91 times 0.1, I'm sorry, and is 0.15. Let me rewrite, sorry. Probability of dog and cat is 15%, which is 0.15, divided by the probability of dog, which is 0.91, right? So let's do this. So we have 15 divided by 91, which is as 15 over 91 as our answer, right? So I hope it's absolutely clear. So I hope whatever questions we have taken so far, they're absolutely clear. We'll now move into thinking questions. So let's take a break. So we'll solve those questions in part 2. Feel free to write your comments, share your views, and if you like and subscribe my videos, that'd be great. Thank you and all the best.